Good morning everyone. I hope you are doing well at home, isn't it? Okay. So, dear students, yesterday we learned about the motion of vehicle along plain but curved road. Also, the motion of vehicle in vale of death. The required expressions we obtained for velocity, even for angular velocity. There are few more things which I want to explain regarding the same motion of vehicle along vertical road or horizontal plane road and the motion of vehicle in vale of death. While studying the motion of vehicle in the plane curve road, along this plane curve road, this was a vehicle along plane curve road, the force of friction was acting towards the center of circle. There is again one important thing. The center of gravity of this vehicle or center of mass of this vehicle is not on the surface of road. It is small distance above the surface of road. Up to this point, there is a centrifugal force acting on this vehicle in outward direction. As it is circular motion, it must experience, that vehicle must experience centrifugal force in outward direction. If you observe closely to these two forces, one is force of friction which is acting towards the center, and second is centrifugal force which is acting away from the center. Both the forces are acting on same object but at different points. You know the combination of such two forces. It produces a torque. Means this vehicle experiences a torque, and due to this torque, the toppling of vehicle takes place. There is a concept toppling. The toppling of vehicle takes place. Means the vehicle may, due to action of the torque, the vehicle may fall on the surface. It is called as toppling of the vehicle. मराठीमध्ये आपण त्याला म्हणतो उलटणे किंवा लवंडणे. खाली पडला, एखादा डब्बा वगैरे आपण असा ढकलला तर तो खाली पडतो. एखादा व्यक्ती असेल तो खाली पडू शकतो. त्याला ढकलली उलटणे, एखादं वाहन उलटलं असं म्हणतो आपण, पण एका बाजूला गेलं. हे शक्यतो कुठं होत असतं? टर्नवर किंवा कर्व सरफेसवर. प्लेन रोडवर शक्यतो तसं होत नाही, ब्रेक अप्लाय केल्याशिवाय. पण इथं स्पीडमुळं ती स्पीड जी असते ना मर्यादित असते. कुठं? कर्व रोडवर. त्याच्यापेक्षा वर जर झाली स्पीड तर टॉपलिंगमुळे ते व्हेकल खाली पडू शकतं. तर ही एक कन्सेप्ट त्याच्यातून टॉपलिंग ऑफ व्हेकल. सो ड्यू टू ॲक्शन ऑफ दिस टॉर्क विच इज प्रोड्यूस्ड ड्यू टू सेंट्रिफ्युगल फोर्स अँड फोर्स ऑफ फ्रिक्शन, the vehicle experiences a torque, and due to that torque the vehicle may get toppled. So toppling of vehicle on the surface of horizontal curve, this is the concept of this toppling. Now in case of the vehicle which was moving in vale of death like this was the circular motion of that object, this was normal reaction, this was force of friction, this was weight mg, this was normal reaction. Experimentally, it was observed that this force of friction is less than or equal to the normal reaction. That is mu s into normal reaction. Experimentally, in last lecture, while giving the expression for speed of vehicle, I only use here equal to relation. But actually, in practice, there exists less than or equal to sign. So this force of friction is always less than or equal to this normal reaction. It is mu s into n, and we know that this mu n, that is normal reaction, but this normal reaction is equal to, it is m into v square upon r, and this Fs is equal to mg. So if we put these two values in this equation, you can write this m into g is less than or equal to mu s into m v square upon r. So finally we can write this as this g is less than or equal to mu s into v square divided by r, or in short directly v square is greater than or equal to, we can say, is equal to r into g by mu s, and finally this velocity is considered to be greater than or equal to this rg by v. So this is the conditional part. The velocity of vehicle in well of death must be greater than or equal to rg by v. If we consider this as less than, if this velocity is less than that one, what happens? Means force of friction is less than normal reaction. If force of friction is greater than normal reaction, then the vehicle, or this due to the speed which is less than particular speed, that vehicle will move in downward direction, in the direction of weight mg. So it will fall down, it cannot perform circular motion. So the speed of vehicle must be either equal or greater than this one. This is the limiting speed of vehicle. So these are the two conditions which I want to explain. It was my wish to explain these things regarding the vertical, that is circular motion of vehicle along plain curve road, and in case of well of death. So in case of this, now we will study the next part of this chapter is the necessity of banking of road. So in such case, that is for plain curve road, condition is that speed must be within a particular limit. We cannot increase the speed of vehicle on plain curve road beyond that limit. If we do so, the vehicle may get thrown off the road, surface of road. So there is necessity to arrange that surface of road in such a way that the speed of vehicle on the road must be increased beyond that limit, that is v equal to mu rg. Beyond that speed we have to increase the speed, then there must be some arrangement of the surface of road. Again, that limiting force is there. To overcome that toppling also, there is some necessity of arrangement of road surface must be in such a way that the speed can be increased beyond that limit. In rainy season, when water falls on the surface of road, the surface of road becomes wet. Due to the wet surface, the force of friction is reduced, and if force of friction is small, again the limiting speed becomes very small. So the vehicle cannot move with the speed beyond that particular limit, and if it happens, it will take very much time to travel on this such surface of road. So there must be some arrangement made on the surface of road, and that arrangement is called as banking of road. So what is necessity of banking of road? There are 2 to 3 points. The force of friction provides necessary centripetal force in case of horizontal surface which is small. Due to such small force, the speed of vehicle is very small, it is not reliable. In rainy season, due to fall of water, the surface get wet. Due to the wet surface of road, the force of friction get decreased, and due to the decrease in force of friction, the limiting speed also get decreased. So to overcome such problems, there is necessity of banking of road. So what is banking of road? Banking of roads. It is very important article regarding this circular motion. So at the turn or curve, the surface of road is arranged so that its outer edge is raised over the inner edge as compared to inner edge through certain angle, and that arrangement is called as banking of road. So This is surface of road, turn or curve surface of road. This is surface of road. This is horizontal surface. At the turn, it is observed that this outer edge of road is raised through small angle over the inner edge like this. So this is arrangement of surface of road, means at the turn the road looks like just inclined surface instead of horizontal surface. Before that turn or after that turn again road surface is horizontal, but on the curve or turn surface of road, the surface of road is kept inclined with the horizontal through certain angle. This angle is called as angle of banking, and such arrangement of road surface is called as banking of road. So this is the turn surface of road. So on such road we have to obtain the speed of vehicle which is greater as compared to that on horizontal surface. So we have to obtain expression for the speed of vehicle on such banked road. So what is banking of road? It is just the arrangement of surface of road at the turn or curve in which the outer edge of surface of road is raised, its level is increased to certain height so that it makes certain angle with the horizontal surface. This arrangement is called as banking of road, and the angle between horizontal surface of road and inclined surface of road is called as angle of banking. तुम्ही एखाद्या टर्नवर परभणीमध्ये शिवाजी पुतळ्याजवळ गेला तर शिवाजी पुतळ्याकडची रोडची बाजू थोडीशी वर दिसते, कलेक्टर ऑफिसकडची थोडी खाली दिसेल. त्याच्या समोर जेव्हा तुम्ही रेल्वे स्टेशन जवळ बस स्टँडकडे जाल तर इकडची बाजू थोडीशी रेल्वे स्टेशनकडची बाजू थोडीशी वर दिसते, तिकडची बाजू थोडी खाली दिसते. कुठेही असेल, आपल्याकडे MIDC मध्ये असेल किंवा आणखी हिल स्टेशनला कधी गेला तर तिथे शार्प टर्न असतात, तिथे तर खूप बाहेरची बाजू थोडी वर असते, आतली बाजू थोडी खाली असते. ही आतली बाजू थोडी खाली ठेवणं, बाहेरची बाजू थोडीशी वर उचलणं, पण हे कुठे असतं? फक्त टर्न किंवा कर्व सरफेस, त्याला म्हणत असतात बँकिंग ऑफ रोड. त्याला मर्यादा असते, विनाकारण किती उचलायला जमत नाही. जसं वेल ऑफ डेथ मध्ये तो अँगल 90 हॉरिझॉन्टल सरफेसच्या होते, तो सरफेस असा केला की वेल ऑफ डेथ होते रोड सरफेस. तिथे ती लिमिटिंग कंडिशन 90 अँगल, त्याच्यापेक्षा वरही नाही करते. त्याच्यामध्ये एक कंडिशन असते 0 to 0 म्हणजे हॉरिझॉन्टल, आणि वेल ऑफ डेथ मध्ये 90 हा अँगल मध्ये असतो. लेस दॅन 90 ग्रेटर दॅन 0 एवढा अँगल तुम्ही रोडचा ठेवू शकता, पण कुठं? रोड सरफेस जिथं टर्न असतो किंवा कर्व असतो त्या ठिकाणी कुठेही नाही जमत. सो दिस अरेंजमेंट ऑफ रोड इज कॉल्ड बँकिंग ऑफ रोड. कसं व्याख्या करणार मराठीमध्ये साध्या सोप्या भाषेमध्ये? टर्नवर म्हणजे जिथं रोड टर्न झालेला असतो, वळण असतं, त्या वळणावर रोड सरफेसची बाहेरची बाजू ही थोडीशी वर उचलली गेलेली असते, मटेरियल तिकडे जास्त टाकलेलं असतं. आतल्या बाजूपेक्षा काही अँगल बदलून हा असतो समांतर सरफेस, हॉरिझॉन्टल सरफेस, हा असतो इन्क्लाइन सरफेस. यांच्यामधला जो अँगल असतो त्याला म्हणत असतात अँगल ऑफ बँकिंग. आणि अशी अरेंजमेंट रोड सरफेसवर जी असते तिला म्हणत असतात बँकिंग ऑफ रोड. अशा सरफेसवर आपल्याला एखाद्या व्हेकलच्या स्पीडचा फॉर्म्युला तयार करायचा. इथं गृहीत धरायचं परत एकदा, एक व्हेकल आहे, consider this vehicle moving along this curved road banked at an angle theta. याचे एक्सप्लेनेशन कसं करणार साध्या सोप्या भाषेमध्ये? जेव्हा फिगरचं एक्सप्लेनेशन, फिगर वाचता यायला पाहिजे फिजिक्स मध्ये तुम्हाला, त्याला वाचायचं कसं बघा. फिगर काढली, काढत असताना मी जे सांगणार ते फिगर मध्ये काढणार. कन्सिडर व्हेकल ऑफ मास m, इट इज मूव्हिंग विथ वेलोसिटी v on curved road of radius r banked at an angle theta. या चार महत्त्वाच्या कन्सेप्ट त्याच्यात आहेत, टर्म्स आहेत. व्हेकल आहे, त्याचं मास आहे m, इट इज मूव्हिंग विथ वेलोसिटी v on a curved road of radius r banked at an angle theta. आता ते फिगर मध्ये दाखवलंय. When the vehicle is on the surface of road, जेव्हा हे व्हेकल सरफेसवर असेल, द फोर्सेस ऍक्टिंग ऑन द व्हेकल आर, नंबर 1, इट्स वेट mg which is acting vertically in downward direction. This weight of vehicle is acting vertically in downward direction like this. So this is weight mg. Usually नेहमी कुठल्याही पदार्थाचं वजन तुमचं आमचं प्रत्येकाचं वजन हे व्हर्टिकली डाऊन डायरेक्शनला काम करतं. वाहन कुठल्याही सरफेसवर असेल तर त्याचं वजन सुद्धा डाऊनवर्ड डायरेक्शनला काम करतं. सो वेट इज ऍक्टिंग व्हर्टिकली इन डाऊनवर्ड डायरेक्शन. Second part is their normal reaction. This normal reaction is always perpendicular to the surface, and here surface is inclined one. Therefore, normal reaction is like this. Inclined, perpendicular to the inclined surface. This is normal reaction. You can write this as N or capital R. This normal reaction is always perpendicular to the surface. What happens if we take this surface to horizontal level? This normal reaction will move in this direction and it becomes perpendicular to the horizontal surface. Now it is inclined, therefore normal reaction is also inclined. So this normal reaction is a vector quantity. It can be resolved into two components. First is vertical component. This is vertical component, and second is horizontal component. We know in last year, that is 11th standard, we study resolution of vector. So this is a vector. It is resolved into two components. This is angle theta, which is equal to this angle of banking. असा असताना अँगल 0 असेल, जसं तुम्ही याला वर 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 सरकवाल तसा त्याचा अँगल वाढत वाढत जाईल थीटा. जसा इथे झाला तसा तो इथे येतो. आता जर आपण हे असं आणलं असतं, नॉर्मल रिएक्शन कुठे राहिली असती, याला पॅरलल राहिली असती, म्हणजे त्याच्यात अँगल किती आला असता 0. जसं तुम्ही याला वर 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 सरकवलं तसे नॉर्मल रिएक्शन थोडी थोडी सरकली याच्या तुलनेत किती अँगल मधून थीटा. तसं इथं थीटा असतो तोच थीटा इथे घेत असतात. सो this is adjacent component, it is n cos of theta. This is horizontal component, it is n sin of theta. Now the figure is completed. For optimum speed, एक limiting speed जे असते त्याचे मॅक्सिमम म्हणा वाटलं तर मॅक्सिमम स्पीड साठी ही फिगर आधी कंप्लीट झाली. काय काय झालं बघा. कन्सिडर अ व्हेकल ऑफ मास m moving with velocity v on curve road of radius r banked at an angle theta. When the vehicle is on the surface of road, that is on banked road, the forces acting on vehicle are its weight mg, which is acting vertically in downward direction. Second, the normal reaction, which is perpendicular to the inclined surface. This normal reaction is a vector quantity. It can be resolved into two components. First is n cos theta, which is in perpendicular direction, that is upward direction, and second is n sin theta, which is towards the center, that is horizontal component, towards the center of circle. And we know that this is horizontal component which is acting towards the center of circle. It provides the necessary centripetal force for the motion. Therefore, we can write this as n sin of theta is equal to this n sin theta is acting towards the center of circle, which provides necessary centripetal force for the circular motion. So n sin theta is equal to m v square upon r. Call this as 1. And this n sin theta, which is opposite to mg, means this n sin theta must balance the weight of the vehicle. Therefore, n cos of theta balance the weight of vehicle. So n cos of theta is equal to mg. Call this as 2. So these are the two equations. How we obtain these equations? This n sin theta is acting towards the center of circle. It provides necessary centripetal force for the circular motion. If the road surface is horizontal, instead of sin theta, there was a force, frictional force. So instead of friction force, here in this case, initially we consider friction force to be negligible. Then we will study the effect of friction force again. So first, excluding friction, this n sin theta provides centripetal force and n cos theta opposed to this mg means it balances the weight mg. Now dividing equation 1 by 2, therefore you can write n sin of theta divided by n cos of theta is equal to m v square upon r into 1 by mg, this mg. So you can write this as n get cancelled, sin theta upon cos theta is tan of theta. Here m get cancelled, v square by r into g. So using this relation we can write velocity equal to therefore v is equal to square root of this rg into tan of theta, and tan of theta, that theta equal to you can write tan inverse of v square upon rg. So these are the very important relations regarding the banking of road. First, the maximum speed of vehicle on banked road, it is equal to square root of rg tan of theta, and angle of banking tan inverse of v square upon rg. So angle of banking definition is the angle between horizontal surface of road and inclined surface of road at the turn or curve. It is called angle of banking. The expression for angle of banking is theta equal to tan inverse of v square upon rg, and expression for velocity is v equal to square root of rg tan of theta. We know that if we put here 30, tan of 90, tan of 90 is infinity. So we cannot arrange this road such that the outer edge of surface is raised through 90 degree. It will like a wall. We cannot drive a simple vehicle on the surface of wall. So it is possible only in well of depth. So this is the maximum speed of vehicle, beyond which we cannot increase the speed. So this is the maximum speed of vehicle on banked road. Here again one thing must be remarked. This outer edge is elevated. In this triangle, if we use, suppose this is L, or this length of side is suppose L and this is suppose H. What is sin theta? The sin theta is equal to opposite side H by L. So H is equal to L into sin of theta. If the width of road is given and this angle is known, what is the height of this elevation of outer surface of road over the elevation, we can find using this relation. How that road surface is elevated means height of outer edge as compared to that of inner edge, we can find out using this relation if we know the width of surface of road and the angle of banking. In case of turns on railway track, this distance is maximum, it is 1.5 or 1.6 meter in case of broad gauge. If it is meter gauge, then it is only 1 meter. This height may be in millimeters or maximum centimeters. And angle of banking in case of railway track are about 10, below 10 degree, or in few cases it may be greater than 10 degree, but nearly it is always less than 10 degree in case of railway track. In case of road surfaces also, it is acute angle. This theta is always acute angle. So this is expression for banking of road, angle of banking, speed of vehicle on the banked road. This figure may be asked only for 2 marks, separate figure, and this expression may be asked for at least 3 marks or 4 marks also, including definition of angle of banking or banking of road. So this is the article. This article consists, as we learned in this period, it is the necessity of banking of road and actual banking of road. its conditions and also conditions for this velocity and angle of banking. So in next uh, period we will study the remark of this motion, that is including effect of friction. Okay.